Hi everyone. My name is Mika Hatanpää and I'm coming from Nokia, where I'm the head of R&D for the Nokia Airframe Data Center solution. I'm based in Espoo, Finland. The topic of my presentation today is the Nokia Open Edge switch, which is a new design for which we have now started the contribution process to Open Compute project and in there to the Telco and Edge project. This is me. So Mika Hatanpää is my name and I can be reached at mika.hatanpää@nokia.com if you have any further questions or comments about the Open Edge switch design or other Nokia OCP contributions. Then about my presentation today. So as said, topic is Nokia Open Edge switch. I will first give some highlights of the design, what we are contributing. Then I will talk about the block diagram, interfaces, form factor, key components, and about the software platform also that we utilize for a Nokia product that is based on this hardware design. And then in the end, I will give some further guidance and info and links to product information where you can then find more information about the Nokia products related to the Open Edge as well as then other Nokia Airframe product family products. The Nokia Open Edge switch highlights briefly. So the Nokia Open Edge switch is a highly integrated, robust solution targeted for edge deployments. It is fulfilling, for example, NEBS level 3 requirements defined in the GR63 core and the GR1089 core specifications. The design supports indoor and outdoor type of deployments. Typically, we would have indoor deployments, for example, in telco central office locations, but we also have some use cases where we would deploy the Open Edge switch into an outdoor cabinet. The form factor of the product is a 1U half-wide OCP Open Edge sled, following the specifications of the Open Edge chassis and the sled designs that we have also already contributed earlier to Open Compute project. The design is compliant with the OCP Open Edge chassis and the related ecosystem and other components. The system or the design offers a compact footprint with maximum of 5 switches in 3RU or maximum of 3 switches in a 2RU OCP Open Edge chassis. It supports layer 2 and layer 3 Ethernet and IP switching capabilities, and it is compatible with the low latency and high throughput network requirements that are essential in edge and in radio access networks deployments where we would typically use this device. Then briefly about the switch, Open Edge switch block diagram. I will not go to the details of the design here, but for those who are interested in learning more and knowing the details of the design, I would then recommend that you take a look at the specification that we are contributing. The Open Edge switch is based on a Broadcom Monterey switch silicon ASIC with advanced synchronization capabilities, and the Open Edge switch control processor is a high-performance Intel Atom Denverton CPU with 8 cores for an extended feature set and application capability. Typically, we are not just running the Monterey switch control functions on the control processor, but we would also run quite heavyweight application functionalities, and due to that, we have then selected this 8-core part for this device. The Open Edge switch is also part of the Open Edge chassis hardware management ecosystem, and for that purpose, we have an AST2500 BMC on board that then connects the Open Edge sled into the hardware management subsystem of the chassis. Then about the Open Edge switch interfaces. So we say that the product offers and provides optimal capacity in a very small footprint. It has 18 SFP28 ports supporting 10 and 25 gig Ethernet connectivity, and also CPRI for radio access network needs. It also has 4 QSFP28 ports supporting 25 gig and up to 100 gig Ethernet connectivity. These would be the typical uplink ports from this switch. In addition to the switch front panel, the switch front panel has HDMI connectors for synchronization input and output, and also a mini USB debug console interface and a reset button if needed, and also status LEDs. The switch form factor is fully compatible with the OCP Open Edge chassis that has been contributed to Open Compute project already earlier. The OCP Open Edge switch is also compatible with the other components of this Open Edge ecosystem, like PSUs, RMCs, and any other sleds that can be found from the market fitting into the chassis. It is then possible to equip maximum of 5 switches in 3 RU chassis, or maximum of 3 switches in a 2 RU Open Edge chassis. The typical configuration, we would not have just switches in the chassis, but we would also have other types of sleds to implement the needed application use case functionality. Like, for example, in the uppermost picture in this slide, we have an Open Edge 2 RU chassis with 2 PSUs, the RMC, and 1 Open Edge switch sled, and 1 blank panel, and 1 compute sled. Then a few words about the key components of the design. I will start from the rear side of this picture, which is on the left-hand side. There we have the fan units providing the cooling. There's 4 40mm dual rotor fans here. Then also in the rear side, we have the connector that then connects the Open Edge sled to the Open Edge chassis, that is providing the power and the connectivity to the hardware management subsystem. Then the hardware management functionalities are taken care of by the BMC block that is implemented using the AST2500 BMC. Then we have the controller CPU block, which is based on the Intel Atom Denverton part C3758 component, and then that is the memory subsystem of the CPU block is implemented with the standard DDR4 D modules, and on the board we have 2 slots for the D modules. The storage subsystem of the CPU block is implemented with an M.2 module that is then used mostly as for booting up the CPU, and also for other mandatory functions like logging and etc. The lowermost part in this picture, we have the clock and synchronization functionality or subsystem that also includes a double of an oscillator module and the HDMI input and output connectors for the timing and synchronization. Then in the center, we have this Monterey switch block, which is the core of the design here. And then that is then connected to the Ethernet ports or Ethernet and CP ports in the front. We have 18 SFP28 ports. And then in addition, we have 4 QSFP28 ports in the front as well, providing the uplink connectivity. Then last but not least, we also have a possibility to install an accelerator module, which is a daughter card sitting on top of the switch LED. This is not a mandatory part, but for some use cases, we do see that there is a need for an additional accelerator that is then used to handle the packets coming from the Monterey switch. A typical accelerator module could be based on an FPGA or a purpose-built ASIC or SoC component. A few words about the Open Edge switch software platform that is based on Sonic that we are using as the networking platform here. The Sonic switch state service container and the syncd container are in the heart of the configuration, which then translates the user configuration, which means, for example, the VLANs and the forwarding databases into the Monterey switch ASIC. The Monterey switch ASIC is controlled by the Broadcom SDK that also then includes needed kernel drivers. Then, as said, some of the ports can be configured as CPRI ports, and there is a CPRI mapper included in the Monterey switch device. And the configuration of the CPRI mapper is done in a separate thread, which is integrated into the syncd container of the Sonic system. And the CPRI configuration is defined via an XML configuration file, and the networking configuration is defined with JSON and CLI. Where you can find more information about the product. So Nokia is implementing an Open Edge switch product that is part of the Airframe Open Edge portfolio offered by Nokia. Further information about that you can find behind the link in the Nokia internet pages. Also, you can visit the Open Compute Marketplace, where you will find information about the Open Edge chassis and other Open Edge components. The Open Edge chassis is already contributed earlier, and it is an OCP accepted component with full design package available for the ecosystem and other companies who want to benefit of this design and use the design. The Open Edge switch contribution has been started, and we are first contributing the specification of this product and targeting to OCP inspired level. Then lastly, I would like to state the call to action. So I encourage everyone to join the regular OCP Open Edge calls. The OCP Open Edge project is a sub-project under the Telco project, and there are monthly project calls which are handling the design topics related to the Open Edge portfolio, including the switch. As already said, so the Open Edge switch contribution process has been started and is we are targeting to contribute the specification during the second quarter of 2020. You can also find more information from the Open Edge project wiki pages, which are containing the latest specifications, also the draft specification of the Open Edge switch. Also, I would like to encourage everyone who is interested in the topic to enroll and join the OCP Open Edge mailing list. And now that we are in the OCP Virtual Summit, I would encourage and welcome everyone to visit the Nokia virtual booth, where you can find more information about the Open Edge switch hardware and about other Nokia OCP contributions and products. Thank you very much from my side.
Okay, hello, this is Mika Hatanpää from Nokia. I don't see any questions in the Q&A area at least, but I do see one question in the chat area. So the question is that is the software part already merged into the Sonic build image repo? Not yet. So basically we have started this project with the hardware development. The hardware is more or less complete at the moment, and we have now contributed the specification of the product for review to the OCP Open Edge project. And it seems that my audio is very low. I don't try to do anything for that at the moment. We've started this with from the hardware portion, and that's now contributed to the review or to the Open Edge project. Then what comes to the software part, as I said, so we have started to build the product that we are building on top of this hardware piece using the Sonic as a networking platform, and seems to be fitting very nicely to our purposes there. We've not yet done any contributions towards the Sonic project, but I think this is something for us then to consider in the future. Maybe we will need some help on that portion as well. Seems that there are no other questions at the moment. So basically my presentation is here, and if you want to learn more about this, so I will be in the Nokia booth, virtual booth, during this evening my time, maybe morning somebody others time, but maybe now during the next couple of hours I will be available for further discussions in the virtual booth of Nokia. Okay, there's one other question now coming. So is Broadcom the only option? So well, the design at the moment is based on a Broadcom Monterey silicon. So that is kind of the basis of this design, and due to the features of the Monterey switch, for example, Monterey switch is one of the few devices which offers the capability for CPRI connectivity. So basically it has a kind of CPRI to eCPRI or CPRI to Ethernet mapper functionality, which is very important for the use cases that we are targeting to use this device for. So basically as part of the front haul network in the radio access networks. All right, no further questions, so thank you from my side.